Okay, so here we have our energy work power review. Okay, if you missed it in class. So law of conservation of energy, so we got to start off with that. Law of conservation of energy states energy cannot be created, energy cannot be destroyed. Energy just transforms from one type to another. So, can you name off the different types of energy? You got different types of potential energy and different types of kinetic energy. Can you name them off? Okay, well, here they are. Gravitational potential, chemical potential, nuclear potential, elastic potential, and then our kinetic energies, kinetic, electrical, radiant, thermal, sound. All right, so let's look at some examples of energy transformations. We have an energy transformation occurring here as the fluid inside the lighter burns. So we start off with the lighter fluid, which is a chemical potential energy, and it transforms into radiant and thermal, light and heat. Another energy transformation, we have the energy coming from the sun, and it is used to make plants. That energy from the sun is radiant, solar, and it transforms into what type of energy in the plant? Chemical. Any food is a form of chemical energy. All right, here this example is hands rubbing together like that. So the actual movement of the hands is kinetic energy, and that energy is being transformed mostly through the process of friction into heat, into thermal energy. So remember, energy is work. Both energy and work are measured in the same units of measure, which are joules. Key thing to remember. So, talking about work. Work is force times distance. Work is about getting the job done. Both of these guys are moving, okay, the box. And they're moving the box the same distance, okay? The difference is the guy on the top, he's moving it very slowly. The guy on the bottom, moving it very fast. But that doesn't matter. The work is just about getting the job done. It doesn't matter if you do it fast, doesn't matter if you do it slow, is that you get the job done. You move the object from one spot to another. Okay? Force is about getting the job done. Whereas power, which is work divided by time, is more of a competition sort of thing. The faster, okay, so the guy on the bottom, he's going faster, stronger. Look at, he's pushing a bigger box, so more force is required. And he's going farther, okay, faster, stronger, farther, more powerful. Okay, that's what power is about. All right, so the algebra of work and power. So work is force times distance, power is work divided by time. Those formulas, work is force times distance, power is work divided by time. Rearrange those using our triangle. Voila. Many different variations, arrangements of those formulas. And you'll have to be able to rearrange those formulas. All right. So, another little observation here. Work and force, work and power, what do they have in common? They have in common work. So that means we can take these two formulas and we can combine them. Where we have work in one formula, we can replace it with the value of the other formula. So sometimes you can use both formulas to get an answer. All right? So let's do some practice. We have a 72 joule of energy, 72 joules of energy are used to move a 26 Newton box for 35 seconds. How far did the box move? So, problem solving process. I encourage you to work through these first and then check your answer here. Okay, here we go. Problem solving process. 72 joules of energy. Remember, energy is work. 26 newtons, 35 seconds, force and time. Distance is the question. Work is force times distance. Rearrange that formula to solve for distance. Work over force. Plug in your numbers. What are your sig figs? How many sig figs? 2 significant figures. Units, solving for distance, meters, 2.8 meters it is. Next problem, a 32 Newton potted plant hangs from the hook. How much work is done by the hook? Again, pause and work out the problem. All right, here's the solution. Problem solving process, 32 Newton force. What is the work done by the hook? So formula, well, work is force multiplied by distance. So what's the distance? Well, if we have a potted plant hanging from the hook, distance is 0. It's not going anywhere. If it's not moving, there is no work. That's the most important part of this question, is to emphasize the fact that if the object doesn't move, we're not doing work. Okay, so work is 0. Next, 1.7 kilogram ball is lifted from the ground to a shelf 3 meters high. How much work was done? Pause. Work it out yourself. All right, checking your answer. 1.7 kilograms is mass. 3 meters is distance. Work is the question. Work is force times distance. Wait a second. What's the force? Weight is a force. Dun, dun, dun. So force of weight is mass times gravity. Plug in 1.7 mass, 9.8 gravity. There's your force of weight. So work is force times distance, or you can say work is force of weight times distance. Put it all together. There you go. Significant figures, just 2. Your 49.98 rounds to 50. With the decimal point, emphasizing that's 2 significant figures, that 0 is significant. Joules for work. Next question. A 92 kilogram man uses 71 newtons to push a 15 kilogram object 7 meters in 15 seconds. How much power did he use? Pause, work out the problem, come back to it. All right, here we go. 92 kilogram man, 71 newtons, 15 kilogram object, 7 meters, 15 seconds. Question is power. Power is force distance divided by time. When you take the two formulas of work and power and you combine them, and so you plug in your values, 71 for your force, 7 for your distance, 15 for your time, and you get 33.133 sig figs and units of measure, 33 watts. Notice, mass was extra information, not needed there to distract you. Be careful not to let it distract you. If 285 watts of power are used to move a 45 Newton object 9.5 meters, how much time was needed? Pause, work out the problem, and then check your answer here. Problem solving process, 285 watts. Watts measures power, 45 newtons. Newtons measures force, 9.5 meters. That's distance. How much time was needed? Well, our power formula rearranged to solve for time is the only formula that we have that has time in it. But we need W, we need work. So work is force times distance. We have force and distance. So plug in your values for force and distance to get your work. Plug it back into the formula. Now plug that into your formula. Work over power, 1.5 seconds. Next problem, 195 watts are used to move a 25 Newton object for 12 seconds. How far did it go? Pause. Okay, 195 watts is power, 25 newtons is force, 12 seconds is time. Question is distance. All right, distance is work divided by force, but we need work, so work is power multiplied by time. There's your power formula, rearrange to solve for the work. So we figure out our work. Now we plug it into our distance formula. Work over the force, 93.6, sig figs in units, 94 meters. 84 Newton box is pushed for 51 seconds. If it moves 73 meters, how much power was used? Pause. Solve it. Check your answer. 84 newtons, 51 seconds, 73 meters. Force, time, and distance. Power is the question. We take our formulas, combine power is force, distance over time, and we plug in the force, the distance, and the time, and we get a very large, an awkward number that we solve significant figures and units of measure, 120 watts. And that is all I have for the review, the quick and fast one last chance review prior to taking the quiz. Good luck.